extremely important letters in aviation. When the weather really gets bad, these three letters have a special importance for pilots bringing their aircraft into land, for GCA will help them do it safely. GCA means Ground-Controlled Approach, a guidance system for aircraft approaching aerodromes. GCA is made possible by a combination of radar units and two-way radio telephone communication between pilots and air traffic controllers.
Feet per minute. On glide path. 6.
By means of voice radio, GCA controllers talk down the aircraft. They give the pilot a steady stream of heading and elevation information, which enables him to guide his aircraft toward the runway to a point where he can take over visually and land safely. By means of radar, controllers are able to follow accurately every turn and change of heading or altitude of an aircraft in flight as it approaches to land at an airdrome. A surveillance radar element known as SRE is used for tracking aircraft during initial approach. Precision approach radar, or PAR, is used for close-in tracking of aircraft on final approach. Let's take a closer look at the GCA equipment. The surveillance radar antenna is usually located within the boundary of the aerodrome at a site where it will not constitute a hazard to arriving and departing aircraft. This antenna is especially designed to produce a beam with altitude coverage up to at least 8,000 feet. As the SRE antenna turns, it passes through the entire 360 degrees of azimuth and sweeps the surrounding area with a stream of radar pulses. If an aircraft comes within range, some of these pulses are reflected back to the antenna. The reflected pulses are then transmitted to radar scopes, where GCA controllers see them as moving spots of light, or blips, as they're called. The SRE scope gives a 360-degree picture of the whole area surrounding the aerodrome to a range of 20 to 25 miles. All the aircraft flying within 20 to 25 miles of the aerodrome appear in the scope as moving blips. The GCA controller who sits at the SRE scope is known as the director. He guides the aircraft through the initial approach. The GCA director sees the blips through a transparent map of the area overlaying the SRE scope. The map usually has the aerodrome at its center and shows the navigational aids in the area, their holding points, and the approach paths to the instrument runway. Range marks on the scope denoting 5-mile distances from the aerodrome make it possible to determine how far away aircraft are from the aerodrome. The director watches aircraft as they approach with the help of various radio navigational aids to holding points within range of the SRE scope. The inbound aircraft are usually cleared to these holding points by the control center within whose control area the aircraft are flying. If there is more than one aircraft in the area, the director positions them for final approach in such a way that there will be sufficient distance between the approaching aircraft to allow time for each to make the final approach and land. As they come to within 9 or 10 miles of the aerodrome, the director turns them over one at a time to the GCA precision controller. He guides the aircraft through the final approach. The precision controller normally uses 2 radar scopes. One covers the approach path to the aerodrome from about 10 miles out to the touchdown point. The second is exactly the same, but is an enlargement of the last 2 miles. Both scopes are operated from the same precision radar receiving equipment. The precision radar receiving equipment is usually located beside the instrument runway toward its upwind end and about 250 feet from the center line. When an aircraft is properly positioned for its final approach, 9 or 10 miles from the point of touchdown, the precision radar beams pick it up. One antenna sends out a radar beam sweeping from side to side through an arc of 20 degrees. It transmits and receives pulses which provide information as to the aircraft's position in azimuth relative to the center line of the runway. Another radar beam sweeps up and down through an arc of 7 degrees, 1 degree below the horizon and 6 degrees above. This beam provides information as to the aircraft's position in elevation relative to a predetermined glide path. The azimuth and elevation positions of the approaching aircraft are presented on each precision scope in 2 separate displays. The lower display shows the aircraft's position in azimuth, that is, degrees to the right or left of this line, which represents an extension of the center line of the runway. The precision controller uses this lower display to keep the aircraft properly aligned by giving the pilot heading corrections when his aircraft goes too far to the left or right. The upper display shows the aircraft's position in elevation. This slanting line on the upper display represents the predetermined glide path that the aircraft should follow as it approaches the runway. The GCA precision controller uses this upper display to keep the aircraft on the glide path by telling the pilot when his aircraft is too high or too low. The 10-mile precision scope shows elevation and azimuth for a distance of 10 miles from the touchdown point of the runway. Range markers on this scope indicate distances at 2-mile intervals from 10 miles to touchdown. The second precision scope is an enlargement of the last 2 miles. Range markers on this scope are at 1/2 mile intervals from 2 miles to touchdown. The precision controller gives his guidance instructions by radio while watching the precise actions of the aircraft blips on the azimuth and elevation displays. First on the 10-mile scope and then on the 2-mile scope until the pilot can take over and land his aircraft visually. To summarize then, GCA, Ground-Controlled Approach, is a guidance system made up of highly perfected surveillance and precision radar elements and 2-way voice radio channels operated by skilled GCA controllers. Now let's watch this GCA system at work during a typical operation. Area control clears an arriving aircraft, TCA 276, to the holding point of a radio navigational aid in the vicinity of Friendship International Airport. The initial radio contact the pilot makes when he reaches his clearance limit is with Friendship Approach Control.
Friendship Approach, this is TCA 276. Over Friendship Range 4-1 at 4,000 feet. Over.
TCA 276, this is Friendship Approach Control. Roger. Over the Friendship Range, 401 at 4,000. Descend to 2,000 feet on the northeast leg of Friendship Range. Met report, 1630 Friendship. Wind 320 degrees magnetic, 8 knots. Visibility 1 mile. Cloud base 200 feet measured. Slight haze and smoke. Over.
Friendship Approach, this is TCA 276, leaving 4,000 feet now. Request GCA. Over.
TCA 276, contact Friendship GCA on 119.7 megacycles. If radio contact lost, revert to Friendship Approach. Read back. Over.
Friendship Approach, roger. TCA 276 is to change frequency to 119.7 megacycles. If radio contact lost, I am to revert to Friendship Approach. Over.
TCA 276, that is correct. Out.
Friendship GCA, this is TCA 276 on 119.7 megacycles. How do you read? Over.
TCA 276, this is Friendship Director, reading you 4. Over.
There are other aircraft approaching Friendship International, but there is little doubt that the blip moving along the line which represents the northeast leg of the Friendship range on the SRE scope is TCA 276. As there are other blips on the scope, the GCA director should positively identify TCA 276 by requesting the pilot to make a turn.
TCA 276, turn right, heading 050. Maintain 2,000 feet. Read back. Over.
TCA 276 is to turn right, heading 050 and maintain 2,000 feet. Over.
TCA 276, that is correct. Altimeter setting 1030 millibars. Read back. Over.
Altimeter setting 1030 millibars. Over.
GCA controllers have a tremendous responsibility. To direct an aircraft successfully, they must have the complete confidence of the pilot so that he will follow control directions without hesitation.
TCA 276, airport elevation 187 feet. Over.
Roger.
TCA 276, check gyro, heading 050, and do not reset for remainder of approach. Over.
Gyro check completed. Over.
TCA 276, roger. Reduce to approach speed. Perform cockpit check for landing. Over.
Standard GCA and radio telephony communications phraseologies should be used at all times. Pilots and controllers will understand one another more easily, and understanding promotes confidence.
Cockpit check completed. Over.
TCA 276, turn left, heading 020. Descend to 1500 feet. Read back. Over.
TCA 276 is to turn left, heading 020. Over.
TCA 276, position 12 miles east of airport on crosswind leg of approach. Tower, TransCanada 276, 12 miles out on crosswind leg. TCA 276, turn left, heading 305. Read back. Over.
TCA 276 is to turn left, heading 350. Over.
TCA 276, negative. TCA 276, turn left, heading 305. I say again, heading 305. Read back. Over.
Roger. TCA 276 is to turn left, heading 305. 305. Over.
That is correct. TCA 276, runway 28, wind 270 degrees, 8 knots. Visibility 1 mile. Cloud base 200 feet measured. Slight haze on runway. Over. TCA 276, turn left, heading 280. Read back. Over.
TCA 276 is to turn left, heading 280. Over.
TCA 276, on final approach, 10 nautical miles from touchdown. Report altitude. Over.
Roger. Altitude is 150 feet. Over.
TCA 276, if radio contact lost, maintain heading 280. Climb till 2,000 feet and contact Friendship approach. Over.
Roger.
TCA 276, obstacle clearance limit 140 feet for this approach. Read back. Over.
Obstacle clearance limit 140 feet. Over.
TCA 276, stand by 122.1 megacycles for Friendship precision. Read back. Over.
TCA 276 is to stand by on 122.1 megacycles for Friendship precision. Over.
At this point, the aircraft is properly positioned for its final approach. The precision radar beams pick it up, and the precision controller takes over control of the aircraft, while the director continues guiding other aircraft approaching the airdrome.
TCA 276, this is Friendship Precision. Present heading 280 is good. How do you read? Over.
Roger. Reading you 4. Over.
Roger. Do not reply to further instructions. TCA 276, 8 nautical miles from touchdown. Heading is good. TCA 276, set flaps for this approach and check wheels down and locked. TCA 276, approaching glide path. Commence descent now, 500 feet per minute. I say again, 500 feet per minute. TCA 276, on glide path, 6 nautical miles from touchdown. Turn right 5 degrees. New heading 285. Four nautical miles from touchdown. Below glide path 100 feet. Adjust rate of descent. 50 feet too low. Climb slowly. Turn left heading 280. 3.5 nautical miles from touchdown. Returning nicely to glide path. TCA 276 on glide path. 3 nautical miles from touchdown. Cleared to land. 20 feet too high. Adjust rate of descent. 50 feet too high. Adjust rate of descent. Two 2.5 nautical miles from touchdown. Heading 280 is good. On glide path, 2 nautical miles from touchdown.
At this point, the precision controller begins to see the azimuth and elevation blips on the 2-mile scope, which gives an enlarged picture of the last 2 miles to the touchdown point.
Turn right 2 degrees. New heading 282. TCA 276, 1.75 nautical miles from touchdown. Heading 282 is good. Below glide path, 30 feet. Adjust rate of descent. Returning quickly to glide path, resume normal rate of descent. 1.25 nautical miles from touchdown. 1 nautical mile from touchdown. 20 feet too high. Drifting slightly to the left. Turn right 2 degrees. Decimal 5 mile from touchdown, on glide path, on center line. Over approach lights, approaching end of runway. Slight crosswind from right, take over for landing.
This, then, is GCA, a combination of highly efficient equipment and good teamwork between pilots and controllers. A guidance system that can bring aircraft in safely every time.